Hi everybody, this is a little video review of some of our lesson on indefinite integrals. These are just some more examples to look at. So let's get to this. So for number one, this is the constant. We're going to write the 6 in front, x to the 5th dx. And then again, what we're going to do is add 1 and divide by that new exponent. So our function becomes, we're going to have a 6 and an x to the 6 over a 6 plus c. So as you can see, the 6 over 6 goes to 1, and we have f of x is equal x to the 6 plus c. Number 2. This is one of these where we have a exponent in the denominator, and we're just going to move that up. So let's go ahead and take care of our constants first. We're going to put that negative 3 on the outside, and then we're going to have the x to the negative 4. So again, we are adding 1 and dividing by that negative 4 plus 1. So we would get our function that we are finding is negative 3 x to the negative 3 over negative 3 plus c. The negative 3's go to 1. We are left with, now if you can notice this too, you guys, the x to the minus 3 ends up going into the denominator to make it positive. So our function is 1 over x cubed plus c. That was number 2. On to number 3, which was just like number 2. So in this case, we're going to put that negative 2 on the outside, and the x squared is going to turn into x to the minus 2. We're going to do our adding 1. Negative 2 plus 1 as we're dividing. Remember, we're doing the inverse for these. So our function would be the negative 2, and we would have x to the negative 1 over negative 1 plus our c. This negative 2 over 1 is going to simplify just down to a 2, and the x to the negative 1 goes in the denominator. So let's see. This right here, x to the negative 1, make it positive by putting it into the denominator, and there you have that one. Number 4, this is that sum or difference rule where we can just expand this out. So in this case, we are going to have negative 24, our constant on the outside, plus the 16, x to the 3 dx, plus the 6, x dx. So again, we are going to be doing that little power up process. So we're adding 1 and dividing by the 5 plus 1. Adding 1, dividing by the 3 plus 1, adding 1, dividing by the 1 plus 1. So we end up getting, and we're going to have some simplifying to do here. We have the negative 24 x to the 6 over 6 plus 16 x to the 4 over 4 plus 6 x squared over 2, and we have our plus c. So if you notice, these all simplify. That simplifies, this simplifies, and this simplifies. So we end up with negative 24 divided by 6, we get a negative 4x to the 6, plus 16 divided by 4, we get 4x to the 4, plus 6 divided by 2, we get 3x squared plus c. All right, I think we have one more to go. So this kind of combines both sum and difference as well as having exponents in the denominator. So we're going to rewrite this as negative 16 x to the 3 dx plus, we're going to have the 4. And right here, I'm going to go ahead and already move that up. And then we have minus 12 x to the negative 5 dx. So again, the x to the 3 and x to the 5, we moved up and changed the sign of the exponent. So let's just go ahead and do these. We're going to do our add 1, divide by the 3 plus 1. Add 1, divide by the negative 3 plus 1. Add 1, divide by the negative 5 plus 1. All right, so here we go. We have negative 16, x to the 4th divided by 4. We have 4, x to the negative 2 divided by negative 2. We have negative 12, x to the negative 4 divided by negative 4 plus c. So all of these simplifying we can do, the negative 16 and the 4 and the negative 2, the negative 12 and the negative 4. And then the other thing that we can do is take care of these negative exponents by moving those down. So we have at the end here, negative 4, x to the 4, negative 16 divided by 4, negative 4. 4 divided by negative 2, negative 2, we have that x to the negative 2, so that exponent moves down to becomes positive. Negative 12 divided by negative 3 plus 3, that x to the negative 4 becomes x to the 4 in the denominator, and there you have it. All right, so that was just a quick little review of what we worked on for indefinite integrals. If you guys have any questions, let me know. See you next time.